So now that we've talked about the common logs, I want you to evaluate these on a calculator, and then you're going to round your answers. So this will go on a companion video that shows you how to type this into your calculator. But at the moment, I'm just going to fill in the answers so that when you do this, you will be able to, check your answers as you go. So this one is equal to 6. Log base 5 is approximately equal to 0.699. I think I said log base 5. Log of 5 is 0.699. Log of 125 is approximately equal to 2.10. And log of negative 50 is impossible. So let's think about why. Let's look at a few logs that we can easily compute. So since log means log base 10, log of anything that's a nice power of 10 is going to be easy to find. So log of 1 is meaning what power do I take 10 to get a 1? And the answer is 0. Log of 10, what power do I take 10 to in order to get 10? The answer is 1. Log of 100, what power do I take 10 to get 100? The answer is 2. Log of 1,000, what power do I take 10 to get 1,000? Is 3. So that's going to be enough to help us with parts B and C. If I look at part B, 5 is somewhere in between 1 and 10. And so it makes sense that my answer would be somewhere in between 0 and 1. Whereas 125 is somewhere between 100 and 1,000. So it makes sense that my answer would be somewhere between 2 and 3. We can also talk about part D. Notice that all of these are powers. So anytime I take 10 to a power, let's talk about what kinds of numbers I can get. So if I take 10 to any power, let's suppose I plug in a negative number. If I plug in a negative power, suppose I plug in something like negative 2, then that's the same thing as 1 over 10 to the second power, which is still a positive number. Now it's getting close to 0, but it is a positive number. It's not a negative result. If I plug in a 0, I simply get 1. And if I plug in a positive, even if it's an ugly positive, like a fraction, then I'm still going to get a positive number output. So there's no real number that I can put in the exponent that's going to give me a negative result. That's what makes this impossible. And the reason for part A that we got 6 is because if I take 10 to the 6th, then that is what's going to give me 1 million. Okay, so it's obviously much easier to compute this on the calculator than to talk through the ideas, but it's important to talk through the idea of why the answers make sense because it builds your intuitive understanding of what a logarithm is. We will see that logarithms have some common properties. And some of these are shown. I'm going to keep the part at the top of the screen showing because some of these are illustrated up there with our common log. For the first one, this asks the logarithmic question, a to this power is equal to 1. And the answer to that logarithmic question is that if I take a non-zero number to a power, a non-zero positive number to a power, I'm always going to get 1 if that power is 0. And so let's just make it clear that we're talking here about positive values of A that are non-zero. So all of these properties are if we're talking about positive values of A that are non-zero. So therefore, in general, if I get an argument of 1, then my result's going to be a 0 because the exponent that gives me the result 1 is 0. Now this case right here is illustrated by log of 10 is 1. So if I have something instead of log of 10 is 1, if I have log base a of a is 1, then that's going to make a lot of sense here, because let's talk this through with a logarithmic question. If I ask the logarithmic question, a to this power is equal to a, then for all a greater than, oh, I put or equal to 0. I'm backing up. This right here, let's X it out. A has to be strictly positive, you guys, because 0, all of a sudden everything starts breaking down. A has to be positive. So as long as a is positive, then a to the power 1 is what's going to give you the a back again. So therefore, this right here has to be a 1. And for the next property, if I have log base a of a to the x, or if I have a to the log base a of x, either way I'm going to get the x back again. And that comes from the fact that if I ask the logarithmic question, a to the question mark equals a to the x, the thing that makes these two equal to each other is going to be when the exponent is x itself. So we end up with log base a of a to the x is equal to x. And we're going to see that if log base a of x is equal to log base a of y, as long as they're the same base, then their arguments have to be the same as well. So we have all these properties of logarithms that are really good to just know and have at the ready to use, because we use logarithms a lot to simplify things if we need to simplify things. So let's practice using that right now. So if you just have the logarithm properties memorized, then you can quickly get from this to 0, and that's using property 1. For part B, notice how the base and the argument match. So that's matching property 2. So this is equal to 1. Part C matches property 3. So this is equal to 4. And also part D is property 3. So this is equal to 1.3. Now, it is certainly possible to use the logarithmic question to answer all of these. So I'll give you that as an example. For part A, I could rewrite log base 72 of 1 as the logarithmic question. What power do I have to take 72 to in order to get a 1? And the answer to that question is 0. 72 to the 0 power equals 1. But certainly knowing the properties of logarithms is faster than asking the logarithmic question. So it's good to kind of get those down, get those memorized, but always understand where they come from in order to sort of keep them in your mind. We're going to continue and see how we can use property 4 in order to answer some questions, and that is called the one-to-one property of logarithms. So let's label that right here. This guy is called the one-to-one property of logarithms. And it comes in very handy, as you'll see in the next video.